As a corn grower for our family farm, I try to design a systems approach that works in conjunction with nature. And nature's been tough on us this year again in 2020 here in central Illinois. Been extremely cool and damp and lots of rain early, and now the rain's basically shut off. And so how do we, as we take a look in this cornfield, what are we looking for? And how do we design a system so no matter what happens, we are in the driver's seat? And it comes back to three things when we talk about yield. It comes back to early in this plant's growth. In this case, this is V5, and at V5 we know this is the day that this plant's setting how many rows around it's going to be. Every row I can add is worth 10 bushel an acre to me. So if I can take this corn from 16 around to 18 around, and we know the plant breeders have the ability to put as much as 22 around on this corn, it all comes down to early stress. So at V5, we're setting girth. In this case, I hope we're going to be at least 18 rows around. I get excited about that. The second thing is you and I control is nitrogen, and it's the length of that ear. And if you and I start to shorten nitrogen, then that ear is going to start to pull back. Every kernel in length is worth 6 bushel to you. Many times this corn will pollinate 44, and then we'll hang on to maybe what, 36, 38? So where did that other, so if it's 8 kernels that we're missing, where did that 48 bushel go? Usually it's the management. Can we keep enough in this plant in its middle growing season that we can do a really good job? Then we talk at the end about kernel depth. How big those kernels are, that comes from late season management on plant health and nitrogen. So in this case, we start in here with a planter at 36,000. We're in 30-inch rows. We have banded on for nitrogen on both sides at planting time, and we set our planter for 80 units. I'm wanting to get to head-high corn before I need to think about additional nitrogen. That takes me into that getting a good length. Really around the seed itself, though, we have a 360 wave. Remember, the 360 wave is all about closing. How do we get good uniform closing, seed to soil contact, and the wave envelopes that dirt over that seed, and we have a lot of good moisture, and it also positions starter fertilizer. And for our farm, starter fertilizer sets the stage for girth. So if you have a hybrid that likes a good early start, take example Pioneer 1197, it likes to have it right up front. Starter does that for us. So wave was here running on the right side of this row. It was bringing the dirt over the top. And then in this case, we had cast iron closing wheels that were running in notch 1, closing over the top. And I really like our stands. As I dig here, we can see the story that's told. So in this case, as you dig through here, you can see the actual, look at this little blue seed. You can still see the remains of the seed. You can see we planted this seed at 1 3/4 deep. And the first root off is a radical. And this is the one that's going to take that early phosphorus in. And we get that early P in the plant, we're going to have a really good start to this plant's growth. We know we can, increase maturity by 5 days or so, and probably have a 1.5 less moisture at harvest due to early phosphorus. Now remember, soil does not give up phosphate until a soil particle until it's 65 degrees or higher. In this case, we were planting in here, our soils were 55, not 65. So you can see where this radical root was feeding right here where the starter was laid down with wave. We have the 360 dash on our planter. So now we're dashing starter, a 1034-0 in zinc. In our case, it's set at 2.5 inches. And so at 2.5 inches, every time the seed comes down, as the seed comes out of the seed tube, we lay a 2.5 inch band of starter fertilizer down. Now the radical shows that it's right out there very happily feeding in that. So I'm excited about the yield potential of early girth. With the 80 pounds of nitrogen, I'm not concerned that we will not get far enough in the season. We should get a good length of ear. And so right before, when we're at shirt high pocket corn in her, probably about that V9 stage, we'll be through with our Hagee or our deer sprayer with Y drop on it, and we'll put an additional 100 pounds of nitrogen down. So now we've covered all 3 bases. Early we got the starter for girth. Banded with the planter at planting time gives us a good early length. with Y drop of another 100 additional units, so 180 total, we're off to the races and we're looking for a really good harvest.
Let's look at the details that make up the 360 dash system. We plumb our flow to the row unit itself, and at that point we filter here locally at the row, and then pass through a flow meter that gives us the measurement of how much is being applied. So it's important for us to have accurate flow measurement in the dash system. We provide a flow meter, like you see here, that's rated to cover the range of flow that we can apply with dash and plugs right into your dash harness. We also have the ability to run with a flow sense. That'll provide you the ability to map into field view and these sorts of systems. So you have several choices on the flow meters that you could use to operate your dash valve. At that point, we carry on to the heart of the system, which is the dash valve itself. It gives us complete control of the rate and placement of the liquid that we're applying. From there, the dashes of liquid are flowing out through our outlet tube down to whatever attachment we're using to actually apply the liquid near the seed. So as we look closer at the dash valve itself, we've got it mounted here towards the rear of the row unit in a protective tray that keeps it guarded from anything that might be coming through the row unit itself. And the valve is designed to be able to change the rate by pulling back on the plunger in the valve. It's like a needle valve. We're able to control that position of the plunger, and as we do that, we open it more, we get more flow, and as we open it less, obviously we get less flow. And we can move that plunger very, very quickly in just a millisecond or two. So we can pull that plunger open, create a shot, slam it shut, and that creates our unique and consistent dash shot that goes over the top or near each seed. So we're opening and closing the plunger very quickly. So then as that flow is continuing through, we measure the pressure on the outlet side. It gives us a good idea of how crisp the shot is and making sure the valve itself is performing the way it should. We also power this valve electrically with the power that's already here at the row unit. We're not running a new harness. We're picking up power at the row unit itself, and then we communicate over wireless communication back to the hub at the center of the planter that allows us to keep this valve under control and give it the rate that we want it to hit. 360 dash can work with a number of attachments on the planter to actually apply the dash to the seed. You might be working with a firmer like this, and in that case we use an outlet orifice here at the end to get a crisp dash to be created at the seed itself. If you're going to run perhaps a higher rate using 360 wave, we have that ability as well. And applying off the rear of the blade using the same style of orifice here at the end to create crisp dashes at the seed itself. So 360 dash has been designed for 2021 to work with high-speed planters. That could be either Precision Planting Speed Tube or John Deere's ExactEmerge system. And in both cases, we pick up the measurement of when the seed's going to arrive in the furrow by reading the seed sensor that's part of your high-speed system. That tells us exactly when that seed's going to arrive underneath the attachment that's applying the liquid, so we know exactly when to fire the dash valve. As we think about the valve itself, knowing that you're running on a high-speed planter, we've had to design it for a wide range of rates and speeds. We're able to run from as slow as 3 mile an hour up to 10 mile an hour, and from as little as 2 gallon an acre all the way up to 15 gallon per acre. So for 360 dash, it's important that we have consistent pressure at every valve. To make sure that that's going to happen, we've worked with AgExcel to design 2 different pump towers, one that's electric and another that's hydraulic pumps, to be able to provide the pressure throughout our system. Then our center hub is right here on the edge of the tower, and we use this as our master controller to control both the pump tower and send out the commands to all the rows. The hub then is in connection wirelessly back to the cab, where the iPad gives you complete control over the system. So all the control of your dash system is just done here off of an iPad. It's really very simple. We just set the rate that we want to hit. We set how long of a dash we would like, whether that might be a couple inches, 2, 3 inches, and then everything else is done for us from there. We'll report the flow rate by row. We'll let you know if anything looks like it's going wrong, and there's plenty of easy diagnostics, but there's really not much for you to do. So as we're walking across our starter plot here, we're comparing the size of plants and the maturity of plants. And we know a lot of research has been done on starter and shows what we're seeing here. We see a definite response to where we've applied 15 gallon of 1034O through the 360 wave product, and it's on this row here to my left, compared to a more traditional system with no starter added. And here we're seeing about a 6-inch difference in height, as well as a collar advanced maturity here on the plant that had starter applied. So we are seeing the response here in our plots, which lets us go ahead and compare to other passes where we used dash to reduce the amount that we were applying, where we're still looking to see the same kind of response that we're seeing here. So here we've moved only 20 feet away on the opposite side of the same planter pass that applied the 15-gallon continuous stream of our 1034-0. But here on this row, we've used dash, and we've actually saved half of the product. We've only applied 3 inches lined up with the seed, again through the 360 wave. And here you like what you see. Even though we've saved half of the cost, we're not seeing any difference between these plants. We know that can happen because phosphorus is an immobile nutrient. So we're putting it here in this root system. That 3-inch is centered right here where this root system's got access to it. And as these roots intercept that band of fertilizer, we're seeing this plant respond. So we may be spending $30 an acre here. Here we've saved half of that. We've kept that back, $15 that's being saved, and I like the response we see. So the comparison here looks really good. And you can still see as I pull up the plant from the pass further over where none was applied, there's our difference. So significant reduced investment for a strong gain. So as we continue to work our way across our starter plot, we're continuing to increase our savings with our 360 dash system. So the plant in this hand has had a 2-inch band, a 2-inch dash of starter applied, again 1034-0, at 15 gallon per acre concentration. But if you think about the math, because we're only treating 2 of the 6 inches, we've saved 10 gallon and we've only actually applied 5. So our tank's going down by 5 gallon an acre, but the plant doesn't know the difference. What we're seeing here in the root system as we're applying that 2-inch is that this plant's responding just the same as we see on our continuous. And so our savings though is dramatically increased. Here as we're spending $30 an acre, and the other hand with 2-inch, we've reduced that down to 10. So we're going to see the yield advantage here at the end. Like we've seen in past years with our dash plots, we actually in many cases see the 2-inch application out yield the others. And what that is telling me is this plant likes to respond to concentration. It wants a short burst of a lot of fertility, and it sees that kind of savings being realized, but yet the plant's looking the same. So what allows us to apply that concentration? It's really the combination of dash and wave together. We know we couldn't put that much salt directly on the seed, but the wave allows us to get off of the seed 3/4 of an inch to the side and just slightly below our seed depth. So our roots are intercepting that band of fertility, but the seed itself is safe. So now as we've come to the area in the plot where we've put on 5 gallon per acre, you start to really learn the response we'll see in corn plants to starter. And in this case, it's not as clear that there's a difference. Here in this hand, we have a plant that's been no starter applied, just a Keaton firmer. And in this hand, we put 5 gallon an acre continuous stream through the Keaton. And in this case, it looks a lot like you might hear sometimes of where you'd say, I don't know if I saw a difference, or my neighbor ran some starter, I don't think I noticed as much of a difference. And what it's teaching us in this field is, compared to the plants we looked at with 15, we just needed more before this plant was going to respond and show us a difference. So 5 gallon an acre didn't really show much when I compare these two plants. So as we think about applying more, again, there's the seed risk. And that's really what wave is for. That allows us to run more gallons, get to where we see the response that we saw earlier in the plot, and allows us to keep it off of the seed so we're safe. But then as we think about adding dash to the mix, this is really where it comes together. So now I've picked up a plant where we applied 15 gallon an acre concentration in a 2-inch dash. So if you think about the math, that's 5 gallon per acre. And again, in this hand, now I have the plant that had 5 gallon per acre through the firmer. So the amount of starter that we bought is exactly the same between these two plants. So as you compare the response, it really starts to prove the story that concentration is what seems to matter to these corn plants. As we've put in that same 5 gallon per acre in a tight band in our root system, we're getting more response. We're getting more bang for our buck. So a $10 program in both hands, one where we've used wave so we can do more concentration and keep the seed safe. We've also used dash so we don't have to dig deep in the pocketbook. Same dollars, but again, we're seeing the difference. So it really brings home the story of the combination of wave and dash and what starter can do for us when we bring enough to this plant to finish the season right.
So we're out here in some head-high corn here in mid-July, and this corn is our last planted commercial cornfield on June 1st. And you can see that I've dug some roots, and I'm pretty excited about the root ball that we have here and the health of it. At the same time, right out of the center of that root ball, I have the mesocotyle and evidence yet of the seed. In this case, it was a DeKalb seed. And then we're looking here at the radicle. The first root out of that young plant's life is this radicle. So as I'm in this field, I'm thinking about our starter program. How do you and I use starter? In this case, we were using starter on June 1st, not because we were worried about soil temperatures. We're worried about planting date. We know that starter can advance this corn by 5 to 7 days. And so the quicker to harvest we can get it on a June 1st, the happier I'm going to be. And you can see in this root ball, this radicle grew out there, and it's happily feeding on phosphorus early on in this plant's life, realizing even if this field has a high P1 soil test, phosphorus is not available to this root until the soil temperatures get above 65 degrees. So if you're planting on April 15th or earlier and your soils are cool, you're not going to find any P into this plant early, which sets the whole stage for the growing season. So yes, I'm excited as we're digging roots in here. Look at the kind of response we have with emergence, even emergence due to wave, and then the kind of plant growth we had due to getting out of the gate in a really early response. So Tim, as we finish harvesting the plots, we start to analyze the data, what did we find?
When we're trying to study 360-, our goal is to find that we're able to save starter and not decrease yield. So as we work through our different rates, which is 5 gallon an acre, 10 gallon an acre, and 15 gallon per acre, we're comparing to the continuous application, the continuous stream applied of that rate. And we compare both a 2-inch dash and a 3-inch dash. So as we work through the data, we've been studying this over the last 3 years. And we find a pretty interesting trend that we see again this year. So as we look first at the 5 gallon per acre, when you think about 5 gallons per acre, think about it from what the seed would see. So even when we're dashing, we're still applying that same concentration, 5 gallons per acre near the seed. But then in the case of dash, we're able to save some amount in between each seed that we know doesn't have the same ROI. And it shows up here in the data. And in fact, what we find that's interesting is we're actually seeing a yield increase. So remember, we're actually just looking for a tie. For us, a tie is a win because we're saving the starter. But here, as we look at our 5 gallon data, 2-inch, we're seeing 3.4 bushel better than the continuous stream. Not because we've applied more starter, because we've focused that concentration right near the seed, we're seeing that response, 3.4. 3 inches, 3-inch dash, again 5 gallon per acre, 2.7. So it's an interesting trend. We see it in 10 gallon per acre, again 2.4 bushel better than the solid stream, 2.8 bushel better with 3-inch. Again in 15 gallon per acre, it's a consistent trend throughout the plot, 2 bushel better for the 2-inch and 1.9 bushel better for the 3-inch. So have we matched the yield of continuous? Absolutely. In fact, we're seeing here that we're slightly better. And we see that same kind of trend in previous years as well, where we've seen as much as 4 bushel advantage or 3 bushel advantage. So we're excited about 360- by having that control of exactly where the starter goes relative to the seed. We're seeing that we can go after those savings. So this same trend we're seeing in this year's plot is consistent with what we've seen in the past. So as we average the data, take the 2-inch for example, we're seeing over the 3 years about a 2.6 bushel increase over the continuous. So again, our goal is to just tie, but it's very interesting that we are seeing a yield increase over those 3 years.
So Tim, the kind of results we see here in the 3-year average is exactly what we set out with on the design of 360-. We're looking to have farmers get into the starter and understand that not only can we raise yields, but we can save a tremendous amount on our starter program. If you look at this year's 2-inch dash, which we've been using now on our farm the last 2 years, and we look at an increase of 3.4 bushels times $4, that's $13.60 an acre. Take on top of that the $21 savings by using 2/3 less starter in a $30 per acre program, we're now looking at $34 an acre return. So the kind of returns we've seen here is what we set out to do. I look forward to you experiencing that on your farm.